Yeah, so good morning, guys. Thanks for coming so early today after base party. Yeah, I guess Ola told you everything about me. I am here to talk to you about multiple databases, but yeah, first, how many of you read the documentation of Django about multiple databases? Okay, and how many of you actually use multiple databases with Django? Okay, that's nice. I have like something for everyone, for new guys and for professionals. Just keep in mind that it will be my story, so it won't be like everything going through the documentation. It will be my story, based on actual events and code here. Yep, so we start with SetGem. SetGem is a startup. I have joined 4 years ago. Basically, it's something like Google Reader for, but for TV. TV is like more popular than RSS feeds among like normal people, I guess. Oh, by the way, rest in peace. So at first, we thought that like getting all the TV from the internet would be like easy. So this backend part was like crawling the internet, taking all the sources from Netflix, from Amazon, and the front-end part with like scalability, some buzzwords like Ajax, Facebook. That would be the hard part. But then it turned out that backend kept evolving and evolving. And that's how we ended with, yeah, I will talk about it in a minute. That's how we ended, how we have gone from business to client solution to business solution. Because like in a startup world, when you have like a hard technical problem and you have only 4 or 5 people, it's very hard like to concentrate and not to concentrate, but to do both of these things at once. So we changed to business, then something changed. We were bought by Motorola. I guess you know these guys. Basically, by one part of Motorola, there is Motorola Solutions there, but that's whatever. Motorola was bought by Google at the same time, so it made it funny. Yeah, something like this. And then Google thought that like the home business and all of 29,000 people are like too much for them, so they spit us out. And now we are in Aris. So yeah, basically that's the story of SetGem from the last 4 years. I have been in the same office, and I worked for 4 different companies. And the main problem was that when I created a sticker for our laptops, after like 2 months, it was already like I needed like to change it. There was no Google, there is Aris now. So okay, so that was a digression. Let's go back to multiple databases. So yeah, one more thing was that we have changed 4 companies. We have changed it from like front-end based development, like mostly front-end in the like higher sense, like in the more general sense, like all of the web services are front-end for us. So we have changed to backend mainly. We have been in 4 different companies which mainly use Java. The requirements did change, but we didn't change from Django to any other stack. So yeah, basically we came to Django for the views, but we stayed for the ORM. Yeah, for me, ORM is really amazing. So basically, you can think about solutions on this scale, from needing to write tedious queries by hand, and then on the right side, you have like to learn a whole new language, like in Hibernate. And Django ORM is somewhere like there. SQL Alchemy is here. I hope you no one will kill me for that. That's my opinion. Yeah. So let's talk more about backend. So that's how our 1 year ago, this is how our solution worked. Right now it's a little different, but basically, as you can see, it's a search engine. We have crawlers at the top. There is cloud, so it's buzzword compliant. Then we normalize the database. Then there is some magic, like classification. Ania Warzecha told you yesterday about, no, not about classification, but about recommendations, so I won't talk about this part. And then we get clean data. And one thing that is common here is that there is database. So we start from fetching sources from the internet, but then at the end we must store them somewhere. And also, during the classification, we also take into account all sources. So, we must also fetch data from the database. And one more remark: it's not big data. It's only 120 gigabytes uncompressed or something, so it fits in RAM, basically. That's one of the things. Some people tell me that they have 1 gigabyte and it's big data. Okay, so that's how it works. This slide was about just one server. We have multiple servers that go through the queue. And we have also one worker that generates feed for our clients, that they can take and produce something from it or use it. And you can see that there is this database in the center, and from looking at this stack, you can see what will be the performance problem here. So what was, yeah. So basically, when you think about this, the server on the right, the feed server, it just needs to read the database in the sequential order. And the workers on the left, they are doing random access to different parts of the data. So that's one of the things. With one database, it's very hard to optimize the engine for such loads. So Slave would be great. That's what we thought 3 years ago. Unfortunately, it was 1 year before MultiDB. So basically, we couldn't do anything about it until our nice DevOps thought of a solution. And the solution for DevOps is always environment variables. Okay, let's do it. We have different Django installations, so we can just force some of them to use another database. It worked, kinda. Still, a lot of data was unnecessarily duplicated because the slave would need to work on the whole data. Configuration was, there was a lightning talk about configurations by environment variables, but I'm not a fan of it. And all of the issues I will see. And then MultiDB came. And it allowed us to, there will be some talk about MultiDB here. So at first it allowed us just to store our databases in the settings. We could add another database that would store all the data that we don't need on default on Slave, all the data that we can get just from the web. And when you think about the API, I know that half of you have read the docs, so you know it. The API is really beautiful. You have this database option that you can pass to nearly every command to Django. You have using. You have DB manager. These are basically the same thing. They allow you to change the database that you use for the queries. Of course, when you think about it, it would be totally tedious and error-prone to write using everywhere. So that's why we have routers. I haven't heard about solutions similar to routers in any other system, so they are pretty great. This is like the simplest router. The router needs to have at least one of these methods, like db for read or db for write. And basically it takes model and it returns the database, the key of the database that you want to use. So that one would just store all our models from the app named app in the appdb. Of course, that's the same if the router returns none. It basically means that I don't know anything, let's ask another router about it. There are also two other queries. They are more used, like allow relation is used for a verification to see whether foreign keys from one model to the other model are allowed. So here, for example, when we store all models from app in the appdb, we can't have any foreign keys from other models to the models in app. And there is allow syncdb option, which is basically used for syncdb to see which models should be put in each database. That's how you put it in settings. It's basically Django goes through all routers in order until it finds first one, which doesn't return none. And you can easily implement like multiple patterns, like known patterns, like master-slave, what I have told you about, logical partitioning, so partitioning by application, or horizontal partitioning, so partitioning more by instance primary keys, like this. Yeah, so I guess it's not too hard of codes. Like the line that is in bold is like the main part. We can switch between databases based on primary key. One thing to keep in mind is that you need to have primary key before saving the model, or you won't be. The router won't know where to put the model. There is like switching by app. I have already shown it to you. It only like becomes more tedious when you want to store multiple like models from multiple apps in the same database. So there is one nice trick for it. It's the declarative models way. You add just some attribute. Like, for example, we have TMS crawler here, and we can say that it's a crawler, and then you switch by it. It's pretty easy, but it's really saves on some bugs there. And here is read from slave router. It's taken directly from our code. So there are like even some apps like jobs and feed importer we have somewhere. We also switch by crawler. That's how it works. And here, when you think about it, like, okay, everything is okay, but there is one question. How does the router know whether the query is for read or for write? And this is the answer. No, this is not the answer. This is like one slide before, sorry. This is the thing when I had this question. Like, this was like a long day when I thought that, okay, why does there is self-incremental, it does row delete, our own query, like basically it's like delete, but it doesn't go through Django mechanics for performance. So it basically didn't work. Like deleting all objects didn't delete all objects, it deleted maybe some objects. So what happened? It should work, like row delete, I have tested it, it works. What happened? So this is the code in Django. In Django there is like this nice or maybe not so nice, property for write on each query. And this is the property that Django uses to choose the router method. So basically, if you have your own query set, a plane, okay. If you have your own query set there, and you didn't, it's writing to the database, and you didn't specify somewhere that it's for write, you have a bug. Basically, your app won't work with multiple DB and master-slave. So yeah, we know that query set for write is with underscore, but it's a field that you need to know about. There is like the question of slave delay. I guess that all of the guys who work with multi-DB know it. Basically, you trade consistency for speed there, because slave may be like a few seconds delayed. So there is like this code. This is more application problem than Django problem. This code, and when you looked about update to update show and post process, it wasn't so. It would be hard to spot this problem, but we can see that we update some classified field and then we check for it. In the single database, it would work, but when you have slaves, you might not have. So the slave might be delayed, and after update show, it might be that the classified will still be false in the post process. So basically, the easiest way to solve it is just to not touch the model until the end of the request or the end of the processing of the batch process. But that's not always what can be done if the code is complicated. So of course you have using, that's what we have used in most places. And also I have found, like, basically when preparing this talk, I have found Django multi-DB router. So yeah, it's really nice if you have request response based application. There is a pinning master slave router, which basically uses thread locals. Maybe that's not a nice thing, but you don't need to look at it. To pin, like when you save something to one database, it pins this user and this database to master. So all the reads. So when you save something to the database, all the reads will go to master for some number of seconds. And there is also like a new decorator, like nice to use master, which always forces using master instead of slave. Okay, yeah. So now transactions, as you know it, like transactions basically don't work. You shouldn't expect them to work between multiple databases. But what if you want transaction to work on just one database? So here is another piece of code from our code base. That's basically doing a batch insert. There is like now bulk create in Django. That has an older version of it in our code base. Like now, I think that I should have perhaps committed it. It does replace, so we still use it. And in the bold lines, we can see that we do some transaction, and we commit the transaction. So yeah, so we tell Django to commit manually, and then we commit it by ourselves. And it worked for a while for us, because we use just like this in default database, but it doesn't work in multiple databases for like an easy reason. How do transaction decorators know which database to work on? So the answer is they don't know. They always use default database. And that's another bug. Basically, you must go from this code, which is pretty nice but doesn't work, to code like this. So you use the function like manually, and you check self-db from router. So yeah, about migrations, I don't know if Andrew Godwin is here. So migrations also like started supporting multiple databases like half a year after Django started supporting it. The API is consistent with it, so we have ARM using, and we have also database. But there is still a problem, like, okay, but I want to put in one of my databases some models, and in another I want to put different models. So how to choose which migrations, like on which database the schema migration should work on? And there is like a ticket for it, 370 with extended multi-DB support. It's like 3 years old, basically. It's still open. I guess it will be open, but I will, during the sprints, maybe I will try like to convince Andrew to let me work on it in the new architecture. Because like we need the migrations for different databases. Right now our option, what we choose is like we perform all schema migrations on each database, and we must live with multiple empty models in each database. Like it's not very hard for the database basically, but it's harder for debugging because you like, okay, what does this database contain? No idea from looking at it. And we also always use using in data migrations. That's also like not so easy. Code reviews help for it, but if you are not doing it, you have a bug in multi-DB solution. So okay, so basically that was it. There is just one more thing, like an exercise. So practical training in dodging chainsaws. That's basically row delete query set. That's like a simple method like you would find in any third-party app. It does row delete. There is nothing in it. So yeah, so now the question for you, like how many bugs are in this code when used in multi-DB solutions? So maybe we'll start with one. Who thinks there is one bug? Okay, 2 bugs. 3 bugs. 2 people, okay. 3 people. 4 bugs. More than 5 bugs, 5 or more. And the rest doesn't care, okay. So basically, yeah, that's one part of the code. It's not really a bug, but you must first make sure that you use correct connection. Yeah, so I guess you know that we are not done yet. That's not a multi-DB bug, but we forget to set connection is dirty. There is like a performance optimization in Django. So basically it wouldn't do anything. It wouldn't commit the transaction. There would be rollback because it would think that, oh, we didn't do anything. We didn't say it. We did something. And there is the transaction commit on success, which I told you about. So that was like 3 things. Any more bugs? Who think there are more bugs there? Okay, 3 people. So 3 people are right. There is, of course, for right bug there. So now this code stops looking so nice. What about now? More bugs? Who thinks there are more bugs? Still some people. So, okay, I will ask you about it after the presentation because I didn't find any more bugs unfortunately. So yeah, so that's the question for you. Like, are you sure that there are no such bugs in your code? Because you may switch to multi-DB if you are not using it. And even if there aren't in your code, it's very, very pretty much possible that there are bugs in third-party applications you use, like Django tagging or something. So concluding, multi-DB is awesome, but we need more and better documentation. We need full support for multi-DB in schema migrations, better debugging tools, like I have, that's also one thing I would like to work on during sprints, like why you need transaction decorators, which check that you are not actually decorating some method with a transaction, and then you are committing to like in a whole different connection in a different transaction, because it wouldn't make sense. Yeah, attributes like for write should be made more visible, like something with underscore basically doesn't say to me that it's an API. And that's like a nitpick of mine, like better testing tools for master slave configuration. Okay, I'm done.